Welcome to the Town of Newmarket Wastewater Treatment Facility. My name is Sean Greig and I am the Superintendent of the Water and Sewer Department. The purpose of the following video is to help the public understand the need for the March 2013 $14.1 million warrant article to upgrade the Newmarket Wastewater Treatment Facility. The purpose to upgrade the facility is twofold. First, the current facility is 28 and 44 years old, and the systems inside within the facility have reached their useful life. Second, the wastewater treatment facility has received its new discharge permit, and the permit has a new total nitrogen limit of 3 milligrams per liter. The current facility cannot get down to 3 milligrams per liter. The following video will be a tour of the facility and the components of the facility. Thank you. Welcome to the Creighton Street lift station. My name is Sean Greig with the Town of Newmarket Wastewater Department. The Creighton Street lift station is the last stop before all the wastewater goes to the wastewater treatment facility. On average, this station collects 500,000 gallons of wastewater a day. It comes from 9 lift stations and from gravity sewers. It is located right on the Lamprey River. What happens right now is the station has 2 grinders which actually grind up the material that comes in, and then the water is pumped up to the treatment plant just over the hill. The issues with this station is that what gets ground up reforms and causes a lot of trouble up at the treatment plant, as well as their high maintenance, high energy items. As part of the upgrade, we'd be looking to replace those grinders with a lower maintenance, lower cost item. It's called a screen, which would actually remove the material before it gets pumped up to the wastewater treatment facility. When we actually lose power, we have this generator here that actually runs the Creighton Street lift station. However, if the generator doesn't run, then the system backs up into, will back up into the system and discharge at the boat launch. The Newmarket Wastewater Treatment Facility was originally constructed as a primary plant in 1969. The facility functioned as a primary plant until it was upgraded to a secondary treatment facility in 1985. Since 1985, 2 small upgrades have been undertaken. One in 1990 to add a solids handling building and a belt filter press to watering device to reduce the total amount of sludge that the plant would need to dispose of. From the Creighton Street lift station, the wastewater is first pumped to this building. This building was put in 2000. It's our grit removal building. Inside are 2 cyclone vortex systems, which actually the water spins around. The heavier material goes to the outside of the tank and falls to the center and is removed. And then the wastewater continues on to the primary clarifiers. The primary clarifiers is part of the original plant. The original plant was put in 1969. The primary clarifiers are to remove stuff that settles and stuff that floats. So the primary clarifiers, how they would be used in the new plant is they would be used during periods of high flow equalization, but otherwise they'd be used in the future for possible phosphorus removal, which is another parameter that's coming down the line. From the primary clarifiers, which again, the primary clarifiers are the part of the original 1969 part of the facility. The flow comes here into the secondary part of the plant. The secondary portion of the plant was constructed in 1985. The trickling filters, bacteria lives in the trickling filters. Wastewater goes over the rock media. The water trickles down through the rocks. The bacteria in the rocks consume the carbon source of the food out of the wastewater, removes it out of the wastewater. From the trickling filters, the water comes from the trickling filters, stuff sloughs off the rock, comes into the secondary clarifiers. That bacterial culture that is growing on the rocks actually settles out in here and is removed. Then from here, what overflows goes to chlorine contact chambers. This is also part of the 1985 facility. As to what's going to be replaced, these secondary clarifiers will not be used in the process except for during high flows. So this will be used for flow equalization. The trickling filters, however, will be removed and will not be used anymore. There'll actually be new clarifiers that will go in the place of those. From the secondary clarifiers, the flow comes to our partial flume where we add sodium hypochlorite, which then goes to our chlorine contact chambers. Our chlorine contact chambers just allow time for the chlorine to react and do its job and make sure we get a proper bacteria kill before it goes to the river. The big thing to know about these is that we are going to keep the chlorine contact chambers. They will be reused. There just need to be some modifications to them for the new process. From the chlorine contact chambers, it comes into this manhole, which we add sodium bisulfite to remove the chlorine. Then it comes to our sampling manhole. We have our sampler, and that's where right here we have the 1969 sludge drying beds. They were used to dry the sludge up till 1990. We still use them today when we're emptying the digester. However, this would be going away, and this is where the heart of the process would go. This is where the new 4-stage Barden flow tanks would go. Instead of the drying beds, in 1990 they constructed this building to take care of the solids. What is in here is we actually have a press that actually takes the solids in at about 3% solids. It's kind of a watery solids, and it brings it up to 20% solids. This device in here would be replaced. This is the control room for the press. In here, this is where we dewater the solids. Like I said, comes in at 3% solids. It has a high pressure zone, a low pressure zone, and a drainage deck. Comes off. Once the solid on the other end, it's taken by a conveyor into the garage, and it's dropped down into a dumpster and hauled off to turnkey. As part of the process, we're actually looking at a centrifuge. This press gives us about 20% solids. We're hoping to get up closer to 30% solids, because the drier the cake, the less money you pay for hauling. So we're looking to save money, hauling costs and disposal costs, by putting in a more cost-effective, or actually a process that gets us a drier product. This is our sodium bisulfite room. We put this in several years ago. This is what we use the chemical we use to dechlorinate, take the chlorine out, because we're not allowed to put any chlorine into the river. This would stay. There would be no changes here. This is our parts closet. It holds some of the parts for the facility. It doesn't have enough space to hold all the parts. As you can see, that we're very tight for space here. So these are the primary and secondary digesters. What comes in here is sludge from the primary clarifiers and the secondary clarifiers. We actually heat the primary digester to 97 degrees, which create bacteria, which break down the solids, which makes less solids. It also creates a methane gas, which is stored in our secondary clarifier, and we actually use that in the boiler to help heat the digester and to heat the building. The sludge from the primary digester goes to the secondary digester for holding, and then from the secondary digester it goes over to that press that we showed you that takes it at 3% solids and makes it 20% solids before it's hauled to the landfill. These two tanks would be reused. They get new covers, there'd be some interior work done to them, and they would be holding the sludge from the new plant. They'd be essentially new sludge holding tanks. So these two would be reused. We're actually inside the building of the main plant, this building was constructed in 1969. Again, the primary and second digesters are over on this wall here. They were constructed in 1969. You can see the piping for the digester, the piping system. Again, 1969. We'll go downstairs and look at the pumps. This is our SCADA system. This was put in 2000. This was to get us at the beginning of being able to get alarms through the computer, phones, and to be able to monitor at a location like on a computer, and to make changes at the plant if we needed to from a remote location. So this was the beginning of it. We knew we needed an upgrade, so in the future this would be expanded into the major surveillance system. To my right here, we have our 1969 primary sludge pumps, which we've put a lot of work into them. You can actually see some of the new stuff on them. We've changed out as much as we can on them. A lot of stuff we can't get parts for anymore. We actually had to strip this whole thing down and weld the base, and it's just to a point we can't get parts for them anymore. Over here are my sludge thickener pumps. You can see one's in the process of being rebuilt. We do all our own work here. We actually got done rebuilding the other one, and now we're in the process of rebuilding this one. A lot of the wiring in this place, we've been replacing it as needed, but this is a very hostile environment. It's wet, there's moisture, there's sewer gases, there's all sorts of stuff that eats at all this stuff in this plant. And it gets to a point where some of this stuff is unsafe to work on. For example, the wiring. This is the original 1969 lab, and a lot of the controls need to be replaced. This whole electrical side would be replaced. This is our 1969 generator. We can't get parts for it anymore. On the control panel, we've had someone come in and corncob things together that work. And as you can see, we're lacking space because we're loading up this room. This is our wastewater treatment lab. We do a bunch of testing here. We do the majority of the testing. We actually only send out sludge and toxicity testing. Everything else we do here. We're actually looking to hopefully do nitrogen testing here, but we're actually running out of counter space. We do biological oxygen demand testing, pH testing, total suspended solids testing, 2 kinds of bacteria testing, alkalinity, volatile acids, volatile solids, total solids. But as you can see in here, we're out of room. We have a couple computers, a couple people that share desks in here. One other requirement that we are required to do is we're required to test the wastewater 7 days a week. no matter what. Doesn't matter if it's a holiday, weekend, whatever. Someone is here 7 days a week testing the wastewater that's going out. I would like to thank you for watching the tour of the facility. I hope the tour demonstrated the need for the necessary improvements. The new facility is a reliable facility. It will meet the current new NEPD's discharge permit limits. It'll also make it easier and more adaptable to make changes to meet future permit limits. The current discharge for the wastewater treatment facility now discharges about 30 milligrams per liter of total nitrogen. The new facility will discharge less than 8 milligrams per liter of total nitrogen. That will be approximately about an 80% decrease in total nitrogen going into the Lamprey River and Great Bay from the wastewater treatment facility. It is important to note that this will help us move forward to the established water quality goals for the Lamprey River and Great Bay. Thanks again for watching. My name is Sean Greig, and if you need to call me for any information or email me, my phone number is 659-3093, or you can reach me at sgreig@newmarketnh.gov. Thank you.